Here are several types of lithium batteries: cylindrical, the square aluminum shell, and solid pack. They can either be 3.7 lithium battery cell or 3.2 volts lithium pure 4 battery cells. So my question is, do you know how to choose them when you need to make group a lithium battery? And this time we focus on the issue of choosing application scenarios for common lithium batteries. I managed to analyze from the applications, performance, and the end application scenarios of these three different types of batteries. And as you know, we can't go on without support. We truly appreciate your subs and likes. Let's go on. First is the cylindrical lithium-ion battery cells. The standardized design of the cylindrical lithium batteries make them quite popular in the market. The common models are 18650 and 26720. The numbers represent the size of the battery, like 18650 means it's 18 mm in diameter and 65 mm in height, and 0 indicates the cylindrical shape. The manufacturing process of cylindrical batteries is quite mature. They have good heat dissipation and are highly safe. These battery cells are very flexible to assemble and are particularly good for non-standard sized battery compartments. In particular situations, they're better for devices with limited space but requiring high power output and long working hours. Such as when electric scooters are used a lot, these batteries can provide stable discharge performance. And for some portable power tools like drills, cylindrical batteries can also supply a high current quickly to meet the tool's instantaneous power needs. But these battery cells have a small volume and capacity, so the assembly is rather complicated. For example, this cell has the capacity of 2000 mAh. That means it's 2 amp hours. If you want to make a regular electric vehicle battery like 48 volts, 20 amp hours, you need to assemble more than 100 of them, and that would be very complicated to assemble. However, having a lot of cells isn't necessarily bad, because the risk for each cell decreases. If there are really some defective cells among them, the overall impact will be manageable. So, electric vehicles like Tesla's Model 3 and Model Y series are equipped with nearly 3,000 such 2170 cylindrical cells. And the standard 3.7 lithium cells and 3.2 lithium pure 4 battery cells are also generally interchangeable in most application scenarios. And next, let's talk about this type of battery cells. We call it a square aluminum shell. As you can see, this design provides a large internal space, enabling to contain more active materials. So it's typically used in cases requiring high energy and high power. The sturdy shell protects the internal components better, and the heat dissipation is also good too. So it can operate stably under high power conditions. And one more thing, it's easy to assemble, and the battery pack has a relatively long service life. There's enough space in your battery compartment, and this is the best choice, such as electric tricycles, golf carts, and sightseeing vehicles, and so on. When it comes to lithium pure 4 battery in particular, it's mainly used in energy storage situations, like home energy storage, RVs, outdoor power suppliers. It's fit on heat dissipations and can support stable operation under high power conditions. Previously, you might have thought that the obvious drawback for this type was unstable supply, but now has improved a lot because of the market demand. Just there are more and more retired and reused battery cells of this kind, so before assembling, you need to pay more attention to the quality of the battery cells and do a good screening. And next is this type, the soft battery pack battery. The main feature of these soft pack cells is the lightweight. The design is to fit flexible into all kinds of complex space requirements. And inside the soft battery pack cells, there's gel electrolyte. Its discharge is more stable and it can be made into a high energy density type, able to provide a lot of power in a small size. And also because its shell is thinner, so it's more prone to damage from the physical impact and affect safety. So if there's a gas expansion and swelling, it will be more obvious. So let's sum it up. The cylindrical lithium batteries are suitable for electric scooters and portable power tools, and for the square aluminum shells are the best choice for long-range electric motorcycles and electric cars. And for the soft pack batteries, they do very well in drones and portable energy storage systems. Basically, all three work. But which one to pick depends on things like the size of a battery compartment and what the device needs, and what kind of cell material is easier to get and has a steadier supply. There's one more thing that can help you decide. The 3.7 volts lithium battery works better in low temperature conditions. But in the high temperature conditions, it's no doubt that 3.2 volts Li-4 battery is better. So, no matter what shape of the battery cell you choose, if the place has a relatively long average period of low temperatures each year, I'd suggest that you can go for the Li-ion battery cell type. And now you may ask, which one is safer? Well, to be honest, if the battery quality is good and is paired with a good BMS and the charger, there's no need to worry about the safety issues as long as the used method is correct. Or if you are still interested, we may continue to talk about how to choose the BMS and the charger next time.